Alrighty, I guess we'll go ahead and get started. Thank you very much for joining me after lunch. My name's Tim McMichael. I am a senior support escalation engineer for Microsoft working in the Exchange product out of our Charlotte support headquarters. And one of the things that I like to do a lot is clustering and DAGs and high availability and all the topics that kind of surround that. And that's kind of what we're going to take a look at this afternoon. This presentation is going to be a little bit different in that it's not going to be as Exchange focused as some of the other things. What I tried to do with this material was collectively take the things that I find about the platform, about Windows, and the things that I am explaining to customers on the telephone and the situations we run into, and kind of bring them together in a presentation to kind of arm Exchange administrators with some base knowledge of the foundation for which Exchange is built off of. And that's what we're going to try to do this afternoon. So, clustering. Prior to Exchange 2010, Exchange used to have a very strict cluster resource model. We used to actually inject within a cluster a system attendant, an information store, any number of individual database instances. We used to have a cluster name and a group of IPs, and we would actually rely on the cluster service to handle our failure detections and our failovers and things along that nature. Well, come Exchange 2010, that model was deprecated. Okay? We no longer have a cluster resource model that we actually are injecting into the cluster, but nonetheless, we very much rely on the cluster service in order for a DAG to be successful. And there's just certain things that the cluster service itself does really, really well that it did not make sense to reproduce within the Exchange product. And when I say really well, some people will probably question that, especially some of the guys from the product group. But for the most part, it does a really nice job. And these are the core functions that I think I wanted to show you that we leverage the cluster service for. First is heart beating, right? The ability to actually detect a node's failure to make sure a node's alive. An interface for registry replication. And we'll talk a little bit about that in detail coming up. But a place to write information that I know is going to be reliably transmitted to all the nodes in a timely fashion. A method to maintain quorum, to determine who's online, who's offline, do I have a majority. The method to determine networking between nodes and what network status actually is. And then in the case of Exchange, a place to store our active manager states and actually designate an active manager within the cluster. So let's start by taking a look at cluster heartbeats, right? Clustered nodes use a heartbeating mechanism to determine whether or not a node is actually online, whether or not a node is actually alive. We transmit that information between nodes on UDP 3343. Now, there's certain traffic between nodes that is TCP, that still uses 3343. Generally, when a node is joining the cluster, there's important information that needs to be exchanged. That'll be exchanged over TCP, but once the cluster node is actually joined and is a functioning member of the cluster, we're looking at traffic on 3343. Now, we actually allow administrators to adjust in 2008 and newer the heartbeat interval that comes with nodes. Okay? This was recently a table that was published on a blog post by Eldon, and when I say recently, I just came across it. It's actually been out there for about a year, I think. And I decided to lift it because I think it does a really good job of kind of highlighting the networking changes that we can make between nodes. And it does so in terms of fast failover, a relaxed kind of way to determine whether or not a node is down and what the maximum tolerances are. And as you can see here, we have a same subnet delay, a cross subnet delay, a same subnet threshold, and a cross subnet threshold. Your delays, any delay value you're looking at here, is the number of seconds that must expire to when a heartbeat is not responded to, that heartbeat is considered dead, right? So what we're looking at here is we're saying, in the fast failover scenario, we're saying that if a heartbeat's not acknowledged in 1 second, that heartbeat's considered dead. It's considered lost, right? In the relaxed, if you want to follow kind of a relaxed, you're still using 1 second, and a maximum of up to 2 seconds is what we're recommending. Now, the threshold value you see here is the number of consecutive heartbeats that can be lost before a node is considered to be dead, right? And this is kind of where the differences come in, especially when we look at 2003. If we look at Windows 2003, heart beating was very clear. I sent you a packet, you either responded to it or you didn't. If you didn't respond to it, you were dead, right? That node was down. The problem with that methodology is we know that as solutions are scaling out, especially when we start bringing WANs into the picture, and especially with DAGs, where we're looking at geographically dispersed implementations of Exchange, we needed to have a platform that offered some flexibility. And that's, again, one of the nice things that clustering allows us to do is get some flexibility in terms of the number of heartbeats and the amount of time that we consider a heartbeat to be dead. And you'll see here that this has actually come up a lot. Before, it was about 40 seconds was the maximum you could get in 2008. You can see here that you can now go up to 120 heartbeats at 4 seconds each before they're dead. That's a lot of time, right? Essentially, if you take the threshold times the delay, that's the amount of time it takes to actually figure out that a node is dead, right? Now, this is a balancing act, right? Why is it a balancing act? Anybody? Correct, right? The higher we go with these values, the more heartbeats we allow to be dropped before a node is marked dead, and the longer that it takes to actually figure out that that heartbeat is dropped, the longer it takes the node to be marked out of cluster membership, right? And the problem with that is that you really can't tell, are we having a legitimate problem? In other words, did somebody pull the network tap? Is that machine actually down? Can we actually not get to the resources on that node? Versus, am I having some form of transient issue? Is my WAN coming under pressure? My heartbeats are being dropped, etc., right? You've got that fine line between, yes, I know this node's down, and yes, I need to fail over, versus, no, it's really not down, so I really don't want to fail over, right? Probably one of the biggest problems I have with thresholds overall, though, is that it seems today that as soon as we see that 1135 event, right? The 1135 event says a node dropped out of cluster membership, right? As soon as we see that event, the first thing we do is hit up thresholds and heartbeats right away, you know? And if you look out there, you'll see a lot of blog posts that tell you if you see an 1135, the first thing you should do, up your thresholds and up your heartbeats. And the thing I try to challenge people with is if I update a threshold and I change the heartbeat interval, have I fixed something? It all depends, right? In a lot of cases, you have not fixed anything. There is a legitimate underlying networking issue which fails to be addressed, and you're masking it by increasing the heartbeat thresholds and the heartbeat timeouts, right? So I usually look at these not as a fix and more as a Band-Aid until I've been able to prove that there's a networking issue we just can't fix. And sometimes you run into that. As you see these DAGs, especially ones that have high latency, low bandwidth links, right? And you have customers that are stretching these solutions across those types of links, you're going to have some failures, right? You're going to have some heartbeat packets get dropped. And really, unless you have some great control over that link, there may not be anything that you administratively can do to make that link more robust, right? So therefore, you've got to tune the solution to fit that parameter. But I don't like the fact that what we see commonly is that we're just immediately going to these values, immediately jumping into them, and immediately turning them up without really having that understanding of why it is we're doing it. So I encourage you, if this is coming across your plate, if you up this and fix something, take a step back and ask yourself, did we really fix anything? Is there an underlying problem here that needs to be addressed? And should we be doing something else about it rather than changing these intervals? Right? Questions? Yes?
That is an absolutely fantastic statement. I agree with you 100%. The problem with it is pushback from management who wants you to spend as little time on a problem as possible. They want the quick fix. If that covers the symptoms of what kind of support statement do we have from Microsoft
The problem with that statement is that there's really not a support, in my opinion, there's not a supportability concern here, right? If you're at the default thresholds, are you fully supported? Absolutely. If you decide to move to the relaxed thresholds, are you supported? From where I sit, absolutely. If you decide to move all the way to the max values, are you supported? Absolutely. And you're correct, right? A lot of times, especially in the cases that come across my desk, that's the dynamic that we're working with, is a balance between service restoration and root cause analysis, right? And again, changing these, it's pretty quick, right? It takes absolutely one cluster command to change them. They're very simple to change. The change goes in immediately. It does not take time. You don't have to reboot. There's no really work you have to do other than actually running it. And you're right. I could have a fix in 30 seconds that fixes the symptom, but may not actually be fixing the problem, right? And it is a fine line. And sometimes you have to kind of decide how much time you actually want to put into it. Sometimes tracking these down, by the way, is not easy. You're looking at, in many cases, you're looking at dual-sided netmons, and usually something called netft tracing, which allows us to trace the cluster network driver. And those are usually things that you yourself can't digest on your own as administrators. It usually requires somebody from support to kind of step through those. So it can be actually time-consuming. But the flip side of it is, what are we actually talking about? We're talking when you have this kind of problem and the cluster service is terminating, you're talking about databases moving between nodes, which should be uninhibited, and it should not really necessarily be a cause for dramatic concern. We're not talking about clusters that are down here and every node is down. We're talking about certain nodes failing out of cluster membership, and you're going back. Normally, the symptom is, I want to know why my database has moved from node A to node B, right? In Exchange 2013, the beautiful part about that is, if designed and implemented correctly, most people won't even know it happened, right? It'll just be something transient. You as the administrator are tracking it down. But I do think there's that fine balance between recognizing that, that this is a Band-Aid per se, and actually pursuing what the actual fix is.
I guess what I'm trying to say, and again, I agree with you on that, but it would be really helpful to have that conversation and education with management, with customers, with whoever we need to, if there were a blog post or something that maybe took 3 or 4 common cases where applying the cluster heartbeat timeout change fixed the symptom, and then walk through the steps it took to actually resolve it and what other benefits came from that.
When I post this to the MEC content site, I'll put in the notes a link to Eldon's blog. Eldon is one of our PMs for clustering. He does a great job in his blog post of actually just calling that right out on the table and saying, adjusting these values is great, but you need to ask yourself if you're fixing something. And he does a great job of doing that, and it's right there in the Ask Core blog. And the Ask Core blog would be the equivalent of EHLO for Exchange. So you can consider that content pretty much a support statement. Yeah, I'll post that on there. And by the way, I love questions during the presentation. If you've got something you want to ask, raise your hand, hop up, however you want to handle it. So, any other questions? Excellent. All right. So let's take a look at registry replication. Now, anytime a node is configured in a cluster, we create a registry hive in that cluster on that node under HT local machine / cluster. The only time you should see an HT local machine / cluster hive is when the cluster service has been successfully configured. Okay? If that hive is there anytime that node's not actually a member of a cluster, it usually means there's been some form of failed cleanup, and you need to go in there and clean it up on your own. But within this registry hive is where we store the quorum data for any particular cluster. It's where the entire configuration or that shared view is stored of what resources are present, what groups are present, what cluster properties are set, and things along that nature that is shared across those nodes. We use a process in clustering known as global update management to allow the nodes to accept configuration changes into that registry hive and then push those changes out to the other nodes. And the concept there is that if you are successfully a member of a cluster, then you should be able to take these global updates that are coming from other nodes. And the one thing about writing to the cluster registry is that it's very quick, right? When you write to the cluster registry on one node, those changes are propagated through the node sets in a very timely fashion, which for Exchange makes it a great place to put things that you want all the members of the DAG to know about right away. And you can actually see here, this is what a shot of the cluster hive actually looks like where Exchange is instantiated. And you'll see that you have things like the Exchange key and the Exchange Active Manager key. This is where Exchange is using cluster APIs to inject information into the cluster hive. For example, about database states and DAG network states, which we'll take a look at in a little bit here. And as long as you're, again, as long as you're a successfully participating member of the cluster, this information should be replicating out to everybody in a timely fashion. So if we take a look, each node, again, can write to and read from the local cluster data. And by default, anytime a change is persisted to the registry, it's considered received and processed when all nodes within the actual DAG receive that change. So if a node is functioning and online, it has to process that change in order for it to be committed, right? And again, the registry registry is a great place to log this stuff because of the fact that it's timely. So you can see here, one of the reasons we do this, and I'll show you in the next slide with database states, is that imagine if I was writing certain critical information to the Active Directory. Well, we don't know, for example, do you have 80 site links set at 5 minutes? Do you have 80 site links set at 15 minutes? I work with some customers whose 80 site links are 8 hours. So if I had something that I wanted all the members of the database availability group to know right away, the Active Directory is not probably the best place to put that, right? Not unless I was going to try to write it across 80 site boundaries to make sure that intra-80 site replication handled that work, whereas the cluster registry does a great job of getting this out there. So some of the interesting information that we actually store in the cluster registry from an Exchange perspective. We store database states. We also store information about the DAG networks, and we also store information regarding the log generation that exists on the active node. So this is what the database state keys look like. If you expand the cluster hive and you expand the Active Manager hive, you're going to go ahead and see the DB state keys. For every database that exists in the DAG, there is a registry key that is created in the cluster hive that's associated with that database. The GUID that you see here of the name is actually the GUID of that database. So if you were to do a get mailbox database and you looked at its object GUID, that object GUID is going to correspond with this GUID entry here. That's how you can actually map the two together and know what you're looking at. If you look at the internals of that actual key, so if you pull that actual key up, you'll see several pieces of information about that database which are helpful to us. And I kind of broke it out here for you. So you have active server, indicates the database that the server's supposed to be active on, right? And then you have last mounted on server, indicates the database the server was last mounted on. Now, I know that sounds kind of intuitive, but here's how these keys kind of play with each other. Across the DAG, there exists a primary active manager. And that PAM is responsible for all database movement operations that occur within a DAG. So when you actually fire up, you fire up the management shell and you say, I want to move a database from node 1 to node 2, it is the PAM that is taking those commands and is coordinating that action across the DAG. One of the first things the PAM does is it comes in here and it says, all right, you've told me I want to move a database from node 1 to node 2. So I'm going to change active on server to node 2. And I'm going to leave last mounted on server as node 1 until the move operation is completed. When the move operation is actually completed, then active on server and last mounted on server equal one another, right? So this is a way we can track, was a database in a state change between nodes. Now, why is that important? Why would we want to track that information through the cluster registry? Well, it's not that it may not be successful, but there's only one node in a DAG that's the PAM at a time, right? What happens when that node fails for some reason? Let's say it blue screens, it goes away. another node in the DAG becomes the primary active manager. And the first thing, or one of the first things that node does, is it hops in these state keys and it says, hey, were there any operations that were in progress that I need to finish? And if it finds one of these DB state keys where active on server and last mounted on server were different, it knows that that database was in transit. It now knows that as the PAM, it needs to finish that operation and see that operation all the way through, right? So again, recording this stuff to the registry, having it propagate out fast and having a central store to look for it in is really helpful, right? Now, mount status tells us whether or not the database is mounted or dismounted. And then this is kind of a new flag for us. Is admin dismounted? This tracks whether or not the database was dismounted by the administrator. Now, this particular flag is used if a state change of the PAM occurs, or if we're actually bringing an entire DAG up for the first time, like maybe you shut down all the nodes. We will not automatically mount databases that had been administratively dismounted prior. So before an exchange, if you did not want a database to mount on startup, you used to have to get the properties of the database and check that checkbox that says do not mount this database at startup. With 2010 and 2013, if you actually previously admin dismounted the database, we will not automatically mount it again until you as the administrator come back and say, I want this database mounted. The assumption is that if the administrator dismounted it, they dismounted it for a reason, and we don't want it mounted again until they say they actually want it mounted. So again, that's what the DB state key looks like. Another reason we leverage registry replication within the cluster to actually work in our favor. And again, get that information communicated out as soon as possible. Now, the last log key. The last log key that you'll see in the registry represents the decimal value of the log file for the active copy. So as logs are generating on the active copy, we're injecting into the cluster registry the decimal value of that last log. We are also injecting into the registry a timestamp of when that log file was created. Okay? So constantly, as we're generating, next update, decimal, decimal, next update, timestamp, timestamp. And these are actually recorded under the last log key with a database GUID for the log, and then a database GUID underscore time is what would actually hold the time value. So if we take a look, here's what this looks like here. So you can see I have the last log hive right down here. And within these, you can see the database GUIDs and then the last decimal log file and the timestamp that they were generated. Now, we do this for a few reasons. One, when we're calculating the copy queue of a particular database, we're actually looking in the registry and we're taking this value that we find here, we're subtracting it from the last log that was inspected on the target node, and that will give us our copy queue. Right? That'll tell us how many log files are actually waiting to be copied to the target node. Now, the timestamp here is to help us make sure that the cluster is actually sending and receiving timely updates. What we found is that as we are injecting changes into this cluster hive, not all the time are those updates making it out in a timely fashion. As a matter of fact, sometimes the global update manager process gets stalled. If you've been to Abrams' presentation or you've been to Scott's presentation earlier, there's actually a nice hot fix to help with some of that for global update management. I don't have that number handy, but it's in their presentations if you take a look. So what the passive nodes are doing is as they're looking at this registry key and they're looking at the timestamps, they're comparing it to the local timestamp of the machine. And if we find that the timestamps have not been updated in 12 minutes, we assume that there's a problem with the registry replication process. We assume that we have not gotten good information, and the database copies will go into what I call a self-protection mode. And that self-protection mode is we set the copy queue length at like 9 quintillion log files. Has anybody ever seen that before? Right? Yeah, I mean, you look at it and it looks awful because you're like, how could I imagine to have 9 quintillion log files behind? And what that is, that's a self-protection mode. We've detected, based on looking at the local registry, that we have not seen a last log timestamp change in 12 minutes. So we can no longer reliably tell you that the copy queue you're looking at is actually valid. So think of it, the active node's generating logs. It might have generated 0 through 100, but if the last log that we received replicated was 50, the copy queue should have been displaying 50 to you, but it might actually display 0. So we can't reliably know that we're activating a database that's up to date or that's not behind, especially when we're going through the best copy selection process. So we put that check in, and that's why we stamped that in here. And did we add that in SP1 for 2010, the timestamp? The timestamp. I can't remember. It came with 2010 is when we introduced a timestamp, and we carried it forward with 2013. So, and a lot of times if you ever do run into that and everything is actually running, if you find the node that owns the global update process at that time and you were to reboot it, all of a sudden everything comes back and everybody's happy again, right? And your copy queues look a lot better than they did before. But that's how we track the last log and use the last log key. Yes? No, the local nodes will inject this. It's where the active copy is mounted. Yeah, so because those active copies are spread out across. So as the active copy is generating a log, it updates its local cluster hive, and that is then propagated out to the other nodes. Huh? What did you say? Oh, yes. Dimitri is in the front row here. He's looking stuff up for me just in case. Any other questions? Yes, sir. Sure. Good. Why do we pick 12 minutes? So I'm not going to pretend to tell you why we picked 12 minutes because I don't know. It sounds like a really nice round number. You know, why it could have been 10 or 5 or 12, I have no idea. If it's like how we picked the replication port, it's somebody's birthday. So, you know. So you never really know. Off the top of my head, I don't know. Now, what happens if you delete a key? The answer is it depends, right? If you're deleting one of these keys, Exchange is usually pretty gracious, and we'll just come back and recreate it when we don't find it's there. That's one of the nice things about the Active Manager process and how we track some of this. If you've managed to delete the cluster hive, you get yourself into a slightly more precarious position. Because you're essentially removing the cluster configuration. And if that key is not present and fully populated, the node does not know how to rejoin. So it's not like it knows it was a member of a cluster and it's just going to suck the configuration down from somebody else. You're actually deleting the local configuration. Now, there's restore options for you where you can actually re-inject that hive. 9 times out of 10, what I prefer to do is just evict the node and re-add it because we don't have anything in there we really need to keep. Right? It was definitely more critical on previous versions of Exchange where you had resource definitions that were injected by XRES and things along that nature where just evicting the node and adding it back was not benign. With 2010, that's generally a pretty benign, and 2013 is generally a pretty benign procedure at this point. Any other questions? Excellent. Now, the other thing we like to store in the cluster registry is the DAG network states, okay? And essentially what DAG networks represent is they represent the log shipping channels at the network layer that we're going to use between a given set of nodes. And you can see here, this is what it looks like. It's an XML kind of formatted registry key. There's only one registry key that's there. It lists all the networks that exist across the node. And it gives you your name, what subnets are actually associated with it, and whether or not we're going to be doing any compression or encryption. You can see here's the subnet that's actually associated with it right there. And then these are the states, whether it's replication enabled or whether or not we've set the ignore flag. Again, all these things are stored in the cluster registry. So if you have a particular network, for example, that's a dedicated backup network, that'll be populated within the DAG, but it shouldn't be used by the DAG. So when you actually set replication enabled to false and you set ignore to true, it's getting stamped in this XML blob, and then that's being replicated across all the DAG nodes. And that's how all the DAG nodes can very quickly pick up the replication states or the network states between those nodes. So the initial population of this key, by the way, in 2013 is actually based off of the feedback we get from the cluster network stack, and we'll take a look at that here in a second. Yes? That's all right. Yeah, that is correct. Yep, we'll actually surface the event in the event log right now. And using the event log is actually pretty helpful. I found that there's a delay now, which we never used to have before, where you'll actually see the event populate in the log that says I'm loading a new configuration for networking. But then when I go and I run get DAG network, I see something different. It takes a little bit of time for it to kind of coalesce and bubble back out to the commandlets now. In 2010, it seemed to be a lot more, I should say, quicker. But we also didn't log any of the injection that was going on. And part of that was the change. In 2013, we changed to automatic network detection between DAG nodes. So we actually will take and create the DAG network layout for you, where in 2010, all we did is take the feedback from the cluster network stack, create the DAG networks, and then we relied on you as the administrator to come back and concatenate those networks together so we knew what subnets could talk to who and how, right? So we tried to add a kind of a layer in there where we do it for you, and that's part of the additional logging that we've put in there to actually load that. Okay. All right, so cluster networks, right? We talked about registry replication. Now let's move on to cluster networks. The cluster service itself looks at the interface configuration across all the nodes to determine subnet information and what network interfaces belong to what subnet, right? It then creates these clustered networks where it groups those interfaces together. So this brings up a very important point. Every interface on a DAG node should reside in a different subnet, right? It is not a great idea to have two independent network interfaces, both with IP addresses that fall on the same subnet, because clustering and the DAG does not know how to deal with that, right? It expects every interface to be in a unique subnet. This is very important too. Now, teaming obviously changes that a little bit in that you're taking two NICs and aggregating it to kind of one virtual port, which could then reside in the same subnet. But you should not have multiple interfaces that sit in the same subnet. It's the cluster networks that are then the basis for how the cluster service determines how heartbeat information will be exchanged between those nodes, right? So the cluster service actually has an independent mechanism to look at these networks, to look at these interfaces, determine who has connectivity, and kind of create this map on how heartbeats will be transferred between these nodes. Again, this is the feedback mechanism that is the basis for DAG networks. This is what Exchange is looking at to determine what the initial DAG network states are going to be, what subnets exist across those nodes, and how they will then subsequently be used for log shipping. So this is a screenshot. This comes from 2012 R2, by the way, so most of these screenshots you see here are new. But what you'll see here is you have your cluster networks. So by looking at this right now, I can say that this cluster has at least two unique subnets across it, right? Whether that's two public subnets, whether that's a public and a private, whether it's a public and a backup, you really can't tell that from here. But I can look at the number of cluster networks and know there's at least two subnets in play. And if you get the properties of those cluster networks, you'll see the aggregate interfaces put into each one of those networks, right? Now, this is kind of one of my pet peeves. You can see here that you have node 1 Ethernet, node 2 Ethernet. I really like to, when possible, especially in the interface layer, rename the interfaces. It's always very confusing to look at an IP config, for example, and see local area connection 1, local area connection 2, local area connection 3. It really doesn't tell me a whole lot about what's going on. So I like to make sure that when I'm looking at those interfaces that are going to be bubbling up into these networks, that I'm naming them uniquely. And that helps you manage things. It's also helpful in troubleshooting situations where maybe you want to disable a network. You don't actually disable the one you're RDP'd to. And then you have to wait for somebody to drive 3 hours to go and re-enable it again so you can get back into the box. Right? True story. It happens more than you might think. So I like to make sure my interfaces have some unique names. But as you can see here again, the cluster networks have a state they're up. Now, this is also the method by which the DAG determines whether or not an interface can be utilized for replication. So as you can see here, cluster has a state for the entire network, but it also has a state for the individual interfaces. If an individual interface is up, the assumption by the DAG is that it can be used for log shipping if that network is enabled for replication, right? Now, this brings kind of an interesting paradigm in here in that Previous versions of Exchange, for example, Exchange 2007, if we couldn't make a network connection to the source node, we considered the network to be dead. And then we would switch to different log shipping channels at that point. In 2010 and 2013, if the interface is marked up, even if we cannot ship a log over it, the database will just go into a disconnected state. It actually doesn't switch networks. The only time it switches networks is when the cluster service has given us feedback that that interface is down. Right? That's the basis for which we determine a failure mechanism to move log shipping to a different network. And that's kind of very important as you see customers that are doing testing. They'll do things like block the replication port on a replication network, and they don't see that replication actually shifts over to the public network, right? So there's some differences in the way we used to handle that in previous versions and the way we actually handle that now, and a lot of that's tied directly into the interfaces and the states that we get back from the cluster service itself. Now, I've kind of highlighted this already. The cluster networks that we get from cluster service happen to become the actual DAG networks. With 2013, again, the automatic DAG network detection actually works really, really well. Very few times is it wrong as long as the underlying configuration is correct. And what I mean by that is that when you look at your interfaces, if you're using replication or secondary interfaces, you've actually made sure that you have them marked not to register in DNS, that you've disabled NetBIOS. If you're using routed secondary interfaces, that you've actually injected your static routes and you've tested them and you know that they work, then the DAG network detection generally is pretty spot on the first time. Every time that I have seen come across my desk where the DAG network detection is not correct, it's the result of having an underlying network configuration problem. Missing static routes, interfaces that are in the same subnet but you have more than one interface, and things along that nature. So it's very important when you're implementing this to make sure that you're paying attention to the actual interface settings and you're following the best practices prior to instantiating the DAG. Yes? You know, I literally had a customer where kind of had this conversation over the last week and last 2 weeks. If you read TechNet is very clear in that it says a single NIC DAG is supported, but multiple networks are recommended. I think that, you know, if I had to be kind of forward-looking, I think you're going to see us kind of change that in the next few weeks. For me, I use multiple networks where it adds value to the solution without adding unnecessary complexity. And what I mean by that is I'm working with some customers in the virtualization world. They're taking 4 10-gig ports. They're making a 40-gig channel. And then they're creating 2 virtual switches that are bound to that same 4 ports. What have you accomplished? Nothing. Did you get 2 networks? Stamp. Are you following your recommendation? Stamp. But have you actually made any difference in the underlying solution? No. Right? You're not mitigating failure. You're not really adding any value. And you've now added complexity that does not offset value. Right? And that's really how I look at it. I would say that these days it's becoming more common to move to just a single NIC infrastructure, especially where we're seeing kind of 10 gig E become more prevalent in the data center. The concepts that we had before just don't apply. The other thing that kind of comes up here too is you know, I get into kind of the theoretical bandwidth shaping argument, right? I need to have that second channel, so I'm doing log shipping here and I've got clients here. My problem with that methodology is that what we're looking at when there is a catastrophic failure of the secondary network, the primary network or that client-facing network needs to be able to handle all the log shipping traffic, right? So if you're not designing to handle all that log shipping traffic on the public network anyway, then you're potentially running into problems, you know, when the solution does have a catastrophic failure. And we have seen cases of that. We've seen cases where there's something on the client infrastructure that prevents timely replication of log files. The replication infrastructure has experienced a failure, and now the solution starts to degrade over time because the client network can't handle it. And from where I sit, I kind of call that a design flaw. Yep. 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 Yeah, and see that's a classic scenario right there. So I've got this client-facing network where it spans two sides and I'm using some form of MPLS, right? And then I've got this secondary network that is dedicated for kind of management or backbone traffic. That's a classic example where the value offsets complexity in my mind. Now, where we see scenarios like that where it doesn't is we've got two NICs over here, we've got two NICs over here, and they all come into the same pipe, right? So now I've got a value complexity argument where, yes, I've got two NICs, but when it comes to the WAN, I'm really not, I'm coming across the same pipe. There's a single point of failure there. So you kind of get, to me, you get into that value versus complexity argument.
I had a quick question about
Yeah.
when it does fail over.
Yes.
I've seen a couple times where we have our mapping traffic going across one WAN connection
Right.
between the data centers, and then also we have another connection where it's taking all the replication traffic.
Yep.
We've had that replication network go down before, it would flip over to the mapping,
Right.
and it doesn't flip back.
That is correct. If we change network states for any reason, so let's say we flip from the replication network to the mapping network to actually do any log shipping traffic, once we find a network we're happy with, we stay there. So if it moves from REPL to MAPI, it's going to stay there until you suspend and resume the copy, and then it'll redo its detection and flip back to the appropriate network.
And that's what I do, but I was thinking that because I made that parameter in there that it would.
Nope. Once we find a place that we're happy, we stay there.
Okay.
Any other questions? Thank you very much. Those were great questions, by the way. Yes?
Yesterday, in the architecture session, Ross was very clear on the matter of one or two networks, and he said, only use one.
Yeah, again, I don't, I don't disagree with Ross, right, at all, and nor would I. If there's one thing I know better, it's not to disagree with Ross. But, there's what Ross said versus what's currently published in documentation causes some kind of, it causes a discrepancy. Like I said, the documentation is very clear in that we support single NICs, but it also then follows up with we recommend more than one. So you're kind of left with, okay, I'm supported with one, but you're recommending more than one, and you kind of get in that dynamic. I think single NICs are just fine. And again, I do though also move forward though with saying that there are times when double NICs make sense, as long as there's a value that offsets the complexity of having them, right? And that's the way that I've kind of been approaching it when I talk to customers. I've been using the value versus complexity argument, because just because you can doesn't mean you should, right? And if you're not really accomplishing anything, why? Yes?
So that single NIC suggestion that you're making, is it version agnostic or 2010, 2013?
That should, at this point, it's probably version agnostic. The same support statement we had in 2010 is the same one we carried forward in 2013. Now, whether or not both those docs will see updates should something change, that I don't know. But I would say that at this point, the rationale would probably, I would argue the rationale is the same. You're welcome. Yes. Oh, hold on. Yep. That's okay.
So if you do currently have an environment with single NIC, which is supported, what's an indicator that you could be having a problem? Like, what's the first red flag where you're like, man, I should really segregate these things out?
Well, so the problem is that there shouldn't be any red flags that would tell you want to segregate it out. Because remember my previous comment, you should be able to handle everything on the one NIC, right? So if you're getting to the point where you start seeing copy queues build, and your answer is, I'm going to add a replication NIC, and I'm going to move replication over to it, I would challenge you and say, I think there's a problem with your design. It should have worked just with a single NIC, right? Does that make sense? Because ultimately, if there's a failure of that replication channel, everything's going to go over that NIC anyway. And if you can't replicate logs and service clients at the same time, you don't have a solution that's really working for you. Devin.
So the justification that was previously given for multiple NICs was the cluster could then determine server failure versus NIC failure.
Sure.
What happened to that?
The argument's still the same, right? Except for the fact that the outcome's almost universally the same, right? And that's for me, so Devin's point is, if I have multiple NICs, right, If the mapping NIC goes down and the replication NIC stays up, heartbeat traffic will continue to pass. So I can reasonably tell from the cluster layer that that node is alive but experienced a network port failure. Result, databases fail over, right? I have a single NIC solution where we believe the node dropped out of cluster membership. The node leaves cluster membership, databases fail over. Same answer. So at the end of the day, whether it's a NIC problem or a server problem, the end result's the same. Databases fail over.
I would argue there's a very important difference there, though, which is that replication continues, being in the 2-NIC model, replication continues to that node, even though it's not listed in the active copies. And that can come back, that can keep me from running into troubles if I have another.
Well, you're correct, right? In the single NIC solution, if you actually lose the NIC, you're not only affecting the cluster, but you're also affecting replication. You're correct. And that's why I said, again, value versus complexity, right? There's certain things you accept with going with a single NIC, and there's certain things you accept when you have more than one, right?
When you do have both on the same network,
Yes.
does one take precedence
When I have both on the same network.
for replication, log shipping, and client traffic?
Yeah, the replication will always take precedence for log shipping versus the client network. Yes?
We already set up where you have the mapping network and the production network.
Uh-huh.
You want to convert to just doing everything over one.
Yep.
Best practice for switching over.
Disable the interfaces. Just go to the nodes and disable the interfaces. Should take care of it for you. All right. That was a little bit more in-depth than I thought it was going to be, so we'll go ahead and move on. All right. Now, one of the things that happens here, the Exchange DAG actually takes the feedback that you give it through DAG network management and sets the appropriate cluster flags. And what I mean by that is, if we have a MAPI network, so if we have a network that's been detected in Exchange and has been marked as MAPI, one of the things we do is we set the MAPI flag to true, and the replication flag is either set to true or false. So that's the property of the DAG network. That translates into cluster as a network that is enabled for client use and enabled for cluster use. So what that means is that we can bind IPv4 addresses to it. It can host a cluster name, and that is what should correspond to the public network within that cluster. Now, if you have replication networks, when you set the appropriate flags in those replication networks, you should see that MAPI is false, replication is true, and what that translates into is a cluster network state of cluster only. And what that means is that network is enabled for cluster use, but only for heartbeat traffic, right? So there can be no virtual IP addresses bound to it. There can be no virtual names bound to it. That is strictly a secondary network only for the transmission of heartbeats. And then you have what I call additional networks, right? So if you've got a dedicated backup network, if you've got iSCSI networks, I work with some customers that have management networks. Any of those networks, when you set the appropriate DAG network state, which should be replication false and ignore true, that will translate into a cluster state where we completely disable that network. So no heart beating, no traffic at the cluster layer will pass across that NIC. Same thing with any of the Exchange log shipping traffic will pass across that NIC. And here's what that looks like. This is a big screenshot of it here. You can see here the cluster states of cluster and client, cluster only, and none. Right? So this is a network that I've set to ignore. This is a network where I've set replications enabled, and then these have replication and MAPI enabled. Or potentially just MAPI enabled. It depends on how you set it up. But those are the network states. So we have a pretty tight integration between these networks. And that's one of the reasons why in Exchange 2010, before we had automatic network detection, it was so important that you collapse your DAG networks appropriately so that you got the appropriate cluster network states in there. If you didn't actually manage that, sometimes you'd end up with the wrong cluster states. All right, questions about cluster networking, its integration with DAG networking, how we kind of work together there? All right, let's take a look at quorum. Now, we've defined that for a DAG to be successful, the cluster has to have quorum, right? So a node can only successfully participate in the DAG and host database copies if it's in the majority and it has quorum. Now, the quorum calculation, V divided by 2 plus 1, where V is the total number of votes, okay? So if you have a 4-node DAG, with a file share witness, how many votes do you have? 5, right? You've got 5 votes. So that means that you have to have 3 votes available to you at any one point in time in order for the solution to stay functioning, right? So that's basically the quorum calculation. Now, I point this out because there still tends to be a lot of confusion about what it means to have quorum, right? Again, V divided by 2 plus 1. And in order for a DAG to have databases mounted, it has to be in the majority. It has to have quorum. Now, when DAGs first came out in 2010, what we found that customers wanted to be able to sustain multiple failures. And what I meant by that is you've got these geographically dispersed DAGs, which means you have a set of votes that are at the end of a WAN connection. And you may not control that WAN connection. You have no idea. Is it going to go down? Is it going to be up? But when that WAN connection goes down, you were subject to lose a certain number of votes by virtue of the fact that that LAN went down. So you had customers who were looking at symmetrical DAGs. You put 2 nodes in site A, you put 2 nodes in site B, you had your file share witness in site A, and then when that WAN went down, you lost half those votes. You could no longer sustain any form of failure. So what you saw customers doing was increasing the number of nodes in the DAG, even if they didn't host database copies, to inflate the vote count, right? We were using those additional nodes to add additional votes in the primary data center so we could sustain more failure over time. So you ended up in a situation like this, right? So you have some form of link here. And in this case, look at this. I chose 2 networks. See? All right? Now, don't tell Ross. So you can see here I chose 2 networks, right? So for all intents and purposes, I'm OK at this point, right? Everybody can agree I'm all right? So now when I lose this link, that's when the magic happens, right? So I now have a partition. I've got 2 nodes on the right, 3 nodes on the left. Now, in this case, there's no file share witness involved. So what's going to happen, who wins this argument, left or right? Left, right? So I end up with 3 votes over here, 2 votes on the right, and subsequently, those nodes' cluster services will terminate, and my databases will move. And again, the problem we run into here, though, is can we sustain any further failure at this point? No, right? If any of these nodes were to go down for any reason, all databases would dismount. There'd be a complete loss of quorum across the entire cluster. And that can be a problem sometimes, right? Especially when you're dealing with links that you may or may not have control over. Now, the file share witness really doesn't change this behavior, right? If this link goes down, I'm still OK. When I lose this one, I'm still OK. The difference is I then have a lock that occurs in the file share witness, and my databases will fail over in response to those nodes going down, right? But again here, if I lose the file share witness, am I going to be OK? No. If I lose a node, am I going to be OK? No, right? So this is where you saw administrators adding additional nodes over here. For example, they might have taken dedicated public folder servers, added them to the DAG, and all they had was public folder databases on them. That'll give you maybe 2 extra votes over there, right? So that you could try to sustain additional failures without affecting client access. So in Windows 2008 R2, we gave you a hotfix that allowed administrators to actually control the vote weight of particular nodes. So you could actually run a cluster command, and you could actually say, I want this node to have no vote. Now, that was nice. It worked out kind of well if it was used, with the exception of the fact that you really had to manage it, right? We'll talk a little bit about that in the sense that if for any reason you ever added or removed a node from the cluster, all the vote weights got reset. If you were doing a site resilient activation, you had to remember to reset the vote weights, right? And there was no exchange interface into how a node had a vote. Right? We didn't give you an exchange commandlet that allowed you to adjust this so Exchange was aware of it. And this is where this caused an issue. Because from the platform's perspective, let's say I had an even number of votes. And now I decided to vote weight out one of those nodes, and now I have an odd number of votes. Should an odd node cluster have a file share witness? No, it shouldn't. So that means that you as the administrator would have to go into the cluster and remove the witness. Now, what happens when you run an exchange commandlet that modifies a property of the DAG? The witness comes back, right? And why'd the witness come back? DAG didn't know, right? Our decisions on how the quorum should be configured are not based on an understanding of the underlying votes. It's based on how many nodes are in the DAG. So in that case, you took a 4-node DAG, you weighted out one node, you made it a 3-vote solution, which should not have a witness. And then Exchange says, no, it should, because there's 4 nodes in the DAG. So effectively, the only time node weights could be used with an Exchange DAG is when you were going from odd, odd, or even, even. Because otherwise, it was your responsibility to try to go back and constantly maintain whether or not that node needed to have, or that cluster needed to have some form of witness. Now, let's take our scenario again where we've got this 2-2 split. What you can see here on the right is that I've administratively set the node weights to 0. So how many votes exist in this cluster right now? How many? 3, right? 2, 1 for each node, and then the file share witness, you kind of count that as 1, even though the node that locks it just kind of gets weighted. So, do I have a problem right now if this node goes down? No. Do I have a problem if this node goes down? No. Does everything stay up and running if that node goes down? Yes, right? Because now I lock the file share witness, and I've got 1 because I'm only looking at an aggregate of 3 votes. So this was a great way to say, you know what? I've got these nodes across the WAN. I'm going to node weight them to 0. And if I lose the WAN, I lose all those votes at the same time, but now I can sustain more failures in the primary data center. The problem is, not a whole lot of people are actually using this, number one, because most of them have already kind of weighted out anyway with nodes. And number two, you got to remember the administrative tasks that are associated with that and the fact that it may not be set the way you think it is. You've got to kind of be going back and looking at it. Yes? One of your activation steps, you have to come back and set them to 1. Yeah, and that's another point. This is when we talk about this here, I'm talking purely from the platform's perspective. This does not necessarily make sense from an Exchange perspective because you have no idea. This node would have to be designed, obviously, to handle the load of all the databases that you're collapsing onto it, right? So that doesn't even address the design and performance considerations. This is just strictly looking at it from the platform's perspective. Node weights. Make sense? Right? So then we come through with this thing called dynamic quorum. So we move from Windows 2008 R2 with node weights to Windows 2012 with dynamic quorum. Now, dynamic quorum is cool. I like it a lot, right? To me, it solves a lot of these scenarios that we were looking to fix with node weights and that we were looking to fix by adding more nodes to the cluster. So what dynamic quorum does is it allows us to adjust the number of votes in the cluster based on nodes leaving, right? Now, those nodes could leave because they were shut down. They could leave because they were failed. But as they leave, we will shrink the quorum count or shrink that vote count to represent the remaining nodes that are in the cluster. Now, what's interesting about that is the first rule here, dynamic quorum can only be effective when the remaining nodes had quorum of the original number of votes, right? And that's the piece that a lot of people miss. So for example, if I had a 6-node cluster and I lost 4 nodes at the same time, is dynamic quorum going to help me? No, because I needed to have the original quorum count to begin with before we would shrink to the lower vote count. And again, the idea here is to allow the cluster, to allow the solution to sustain more failures. So again, kind of laying out the rules here, the number of nodes based on quorum of the original vote, then we will shrink it, and we will continue to shrink it as long as we have quorum of the remaining nodes. So what does this look like? So here you can see I start out with a quorum count of 7, right? So there's my witness, 3 nodes, 3 nodes. Everybody can agree that's 7, right? So now I drop the WAN, right? So now I lost 3 nodes on the other side. Does this side here still, does Data Center A still have quorum of the original number of votes? Yes, right? So now my vote count will get down to 4. So if I drop another node out of here, my vote count will go down to 3. If I drop another node, my vote count will get down to 2, right? So you could literally find yourself in a situation where over time you could get down to 1 node. But again, that doesn't mean that you're going to be successful with Exchange, right? If your solution's not designed so that 1 node can handle the load, it's great to have databases online that you can't do anything with, right? Now, there was some interesting scenarios that came up here where dynamic quorum did not help, right? So dynamic quorum itself was not the end-all to be-all in terms of facing multiple scenarios. So let's take a look at this scenario. So I've got data center A and I've got B, and I have a 2-1 split, right? So I've got 2 in one side data center, 1 in the other. What do you think happens when I lose that node? What happens in my quorum count? It goes down to 2, right? Now, what happens when I lose the WAN? What do you think happens here? You're split brain. That's split brain. That's the wrong way to put it. You have no quorum, right? The entire solution goes down. So dynamic quorum did not help here, right? We sustained a node failure. Then we had now, again, these are double failure scenarios, but kind of working through this here so you can think about how this works. You can see here that this is a scenario where this didn't help, right? I lost the server in the primary. I lost the WAN. Everything ended up going down, right? Now, take a look at this, right? Again, dynamic quorum count of 5. I lose a server, I go down to 4. I lose the WAN. What happens here? No quorum, fall offline, right? I've got 2 votes on the left. I've got 2 votes on the right. There is no clear majority. So everything topples over, right? And this is not necessarily an odd scenario. We actually saw some of this with dynamic quorum in some of the cases I looked at, especially where there was a witness configured. Because, yes?
Are there no alternate witness over here?
Alternate, well, you needed to come to my 8:30 session. Alternate witness server has nothing to do with this. Alternate witness is only there for site-resilient activations. Well, this has nothing to do with site-level activations at this point. This is strictly quorum and behaviors of the cluster service. Right, so you can see here again, right, I end up with an even split. There can be no clear winner. Things are going to go down, right? So, now, we've tried to address some of that by moving the bar forward for quorum even more in Windows Server 2012, R2, by giving you dynamic witness. So not only do we have dynamic quorum, but we also have dynamic witness. And what dynamic witness does is it looks at the total number of votes, and if the total number of node voters is odd, and a witness has been configured, we remove the vote from the witness. If the total number of node voters is even, we allow the witness to have a vote. So not only are we dynamically shrinking the votes as time goes on, but we're also looking at whether or not it makes sense for the witness to actually have a vote. So for example, what you can see here, if you look at my screenshots here, you can see all 4 nodes are up, and all 4 nodes currently have a vote, which, by the way, if you have not taken a look at 2012 R2's Failover Cluster Manager, it's awesome, right? All this stuff is now surfaced for you right in the Failover Cluster Manager. You can actually see this. And if you look here, under the cluster hive, under quorum, you'll see the witness weight right here. And you can see right now that the witness weight is 1, which means the witness has a vote, right? So now what I'm going to do is I'm going to take the file share witness offline, and what you'll see is that the witness no longer has a vote. But at the same time that that witness no longer has a vote, we dropped the vote off a node, right? So we made sure a witness was required on an even number of votes. When the witness was not available, we dynamically removed a vote from a node to make sure that the vote count was odd. You couldn't end up in a situation where you had even and even. Does this make sense? Right? So 2012 R2 with dynamic witness has come a long way from where we were at with 2008 and node weights. So if you take a look here, you can see here I lost the witness. We dropped the node count off of here. If I had a failure of the WAN, the secondary data center is the survivor. Now, what you'll notice is the default behavior here is to take the node with the lowest node ID and remove its vote. Now, what's the problem with that in the Exchange world usually? The node with the lowest node ID. Generally, the first one you installed in the primary data center where you'd probably like things to actually stay if the WAN went down, right? And you can see here that those are going to drop off. Now, with that in mind, we actually give you a way to exercise some control over this. There is a cluster property called lowest quorum priority node ID. And what you can do is you can set this value to a node ID in the secondary data center. And what this will do is this will tell the cluster, remove the vote weight from a node that's over here, not from a node that's in the primary. So you can see here, my clusters are all up. Here's my node IDs. So if you do a get clustered node, you can actually see here's the node IDs themselves. And what I'm doing is I'm setting the property to 4, which is the highest node ID of a node in the secondary data center. And when I repeat the same test, you'll see that node 4 is now the node the votes dropped off of. So if we were to look at that previous example I gave you, we would have seen the resources stay alive in the primary data center because that's where the majority of votes existed when the WAN went down, right? So again, some pretty awesome stuff here that's happening from the cluster service that we actually take advantage of in Exchange, and it's come a long way. Any questions so far? Excellent. Now, witness server in a third data center, right? 2 years ago, and I mentioned this morning in my first session, but 2 years ago, you probably would have heard somebody stand here and say, bad idea. Witness server in the third data center, bad idea. Now you're hearing, good, go, right? Witness in the third data center solves it all. There's certain considerations, I think, that you need to understand when you're talking about placing the witness server in a third site. Okay? Generally, the successful installations where a third site file share witness makes sense are going to be your unbounded DAGs, right? Where your clients are not reliant on connecting to resources in a particular data center in order to have access to those resources, right? Now, when you put the file share witness in the third data center, if you are using dynamic routing, right? And what I mean by dynamic routing is we have some customers who have presented where their network infrastructure is smart enough to say the link between A and B is down, I'm going to reroute that traffic through this third leg, and that will route back over to B. When you have that type of infrastructure in place, then the third site witness actually works out pretty well because cluster node state changes, you won't have a node fail out of membership because the heartbeats are just traversing over the network. Now, one of the things to consider there, though, is taking a look at the amount of time it takes for that reroute to occur. One of the things that I found in working with some of these customers, especially in 2008 R2, where your maximum heartbeat tolerances were 40 seconds, it was taking 2 minutes for those routes to converge. So you couldn't do anything at the cluster layer to prevent the nodes from falling out because that's how long it took for dynamic rerouting to kick in. Now with the looser heartbeat intervals, that would be a reason to go back in and increase those intervals maybe to 3 minutes or 4 minutes so that you knew that if dynamic routing was recalculating those routes, these nodes weren't going to be failed out of membership. You'd have an opportunity for the routes to reconverge, the heartbeats to traverse, and then those nodes to actually stay in membership. The other thing I want to point out with the third site witness, if you do not have dynamic rerouting, what you end up with is when you lose the link between the two data centers, the node that gets the first shot at locking the file share witness is the node that owns the cluster core resources. So if you are in a bounded model but are using a third site witness, you need to make sure your cluster resources are kept in the same site where you want those users to run. What do I mean by that? Take a look at this. I've got my file share witness in the third data center, but right now my cluster core resources are hosted in data center B. When I lose this link, one of these nodes that owns those resources gets the first shot at locking the witness, and that's the side that will win. So if you find yourself in a bounded model where people are reliant on accessing email directly in data center A for whatever reason, when those databases fail, they're out of email, right? It's not going to work for them. So you really need to kind of step back, take a look at how your clients are connecting. Does it make sense to have a third site witness? Am I bounded or am I non-bounded? Yes.
Is this version agnostic for DAGs at this point?
At this point, so with 2013, I think it's more of a convincing argument because of the namespace planning. In 2010, it can be done as long as your namespaces are very carefully planned, right? So I would say conceptually from a cluster standpoint, yes, it's version agnostic. As you move up the stack in Exchange, you have to decide whether or not it makes sense. Yeah. Correct. So with that,
To do it on 2010, you have to have them on 2012 servers, though.
that is correct. No. No. No, you can do it with 2008 R2 too. There's just different, you can still stretch a DAG with 2008 R2.
Yeah, but you don't get some of the advanced core.
That's correct. You don't get any of the advanced quorum features. So with that, I'll take any questions. I've got about 3 minutes left. Yes. 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 Yep. In Exchange terms, it would be the PAM. By the way, for those of you that are leaving, I would really appreciate if you take the time to fill out your surveys. Your positive comments are what allow my manager to keep sending me back. I would really appreciate if you take the time to do that. Hint, hint. Yes. Like single AD site? Absolutely. Yep, this is AD site agnostic here. Where your AD sites are going to come into play is transport, right? And I think Ross did a really good job of kind of pointing that out in his presentation, is that you really can't take advantage of any of the safety net transport features when you have the site stretched, because we don't actually shadow that mail in 2 locations, because to us it's all one big location. Yeah, I know. That's, as well as some of these aren't. Yes, Devin.
Does 2013 know about, and 2013 SP1 know about the cluster version?
No. No, and that's why you'll often see in the presentations here that it says that Exchange is not dynamic quorum aware. Essentially what we're saying there is we're saying that we don't give you a flag with setDAG that allows you to disable dynamic quorum. We don't give you a flag in setDAG that allows you to turn it on. Those are cluster properties. If they're set in cluster and cluster's functioning, we'll take full advantage of it. You just cannot manage it through the Exchange interfaces. Yes? Correct. Yeah, you could set the preferred failover order. It just doesn't mean it's going to stay over here, right? That's the thing. Ultimately, that group could end up over there. So unless you're doing something to actually actively manage it and look at it, you might be in this type of situation. No. No, same thing. It works pretty much the same. Any other questions? Well, thank you very much. I hope you guys enjoyed yourself.